like to talk a little bit about the C programming assignment that I sent out via an announcement last week. Okay, so what is this programming assignment? It is a simple computer simulator, but a lot of the work is already done for you. There are, let's just go over the objectives, right? I want you to gain some experience with C program development. Other than simple main.c programs that we've been demonstrating in class, I want you to understand the concepts and implementation of a simple computer simulator. Okay, learn lean. Learn the purpose of the make utility and how it's used to manage complex projects. And then understand the purpose of C header files, right? Now, following the instructions in preparation is very important. There are essentially two camps of people in this class. There's the Windows users, right? And then there's Mac and Linux. So I group Mac and Linux to be, pretty much the same bucket. Now, I know that at the beginning of class, you installed, the Windows users installed Git for Windows, right? Now you got the Git Bash terminal on your Windows machine, all right? And I'll show you that here in a bit. In order to run make, it doesn't usually come with make, right? So for the Windows users, you will need to install make on your Windows machine. So the way that you do that is you have to open up a PowerShell console. You can probably do this in a command prompt as well. And you type this command, okay? Wingit install easywinports.make, right? So I'm going to show you how to do that. So let's go to Windows, right? This is Windows 11. And of course, you guys already have Git Bash installed. So this is what Git Bash looks like. You won't have this key here, right? This is just me and my Git SSH key password. All right, so you don't use this terminal to install make. All right, so you have to open up a PowerShell. So let's see what we got here. We got terminal. We've got, let's just look for a PowerShell. So PowerShell 64, right? So we'll go ahead and open that up. So now that you got PowerShell open up, let's go back to the instructions. And then I'm just going to, so wingit install, I'll just copy this. See. So let's go back to PowerShell. Okay, and then paste that in there. Okay, so the command is wingit. Wingit is like a Windows package manager. A lot of you people probably didn't realize Windows had a package manager. Install easywinports.make, right? Now, you could also just by some strange coincidence, let's do this. Let's just see if we can run make, right? Make. It's not recognized, right? So that's what you'd see. So CLS. So paste that in there. Paste that command. And then hit return. Okay, so the command, once again, is wingit install easywinports.make. So it'll go download it. Do you agree with all the source terms? Sure. What are you going to say? So once installation is complete, okay, path environment. So it automatically modified your environment variable path, right? So let's go ahead and just to make sure that picked up, we're going to close the PowerShell and we're going to go back to PowerShell. Okay, so CLS. So now we're just going to type make. And you should see no target specified. This is Windows users, all right? For Mac OS users, you should already have make installed. Okay. And you get the same command. Now, if you don't have make, then you could probably install it with brew. But I'm pretty sure that Mac users have it, especially once we set our computer up for us, development at the beginning of the semester. All right. So now I'm going to return to Windows, but let's go back to the instructions. Okay. So the very first thing you do once you install Make, then it says navigate. Oh, okay. So first off, clone the following repository to your local machine. So it gives you a link. All right. So let's go to the repo. And let me just move this out of the way. So there's the repo. All right. So where you're going to go in the repo is you go to repositories, C Bootcamp. Now, if you've never used Git or GitHub, you don't really have to, right? What you want to do is just click on code and then download the zip file, right? So I'm going to go there in Windows. Okay, so let's go back to Windows. Oh, hang on 1 second. Let me pull the instructions back over one more time, right? I'm going to copy this link. Copy link. And then I'm going to go back to Windows. Open up a browser. Paste that in there, hit return. All right, so you're at the repo. Then, okay, so these things are not individual, right? So you're going to have to just download this entire repository. And it gives you all these different examples for C code. Along with it, you get Simple Sim right here, right? So code, download the zip file. All right. So once you've downloaded the zip file, you can go to your downloads directory. Linux and Mac users can do the same thing. All right. So I'm just going to move. I'm just close this. I don't need this anymore. All right. Now I'm going to go to my downloads folder just to locate it. So users. This is my username. Downloads. So there's the C Bootcamp. Okay. So I'm going to set that aside. Next thing you're going to want to do, if you haven't already done it, so in your, and you can do this up here. So I'm going to close PowerShell. We don't need PowerShell anymore. So you want to navigate to your dev folder. If you don't have a dev, so open up your GitHub or your Git bash window, right? And let me make this text a little bit bigger. So options, text, and select. So I'm going to make it 14. Apply. There we go. Let me make the window smaller now. Okay. Move this way. Okay. So do a ls, right? And make sure you don't have a dev directory. All right. I already have one, right? So if you don't have one, then it's make dir dev. So cd dev, navigate to your dev directory. All right. So I've got a directory there. So I'm just going to make the directory. Actually, what I'm going to do at this point is just copy over the C programming, right? Just copy this. Copy. Oops, hang on 1 second. Copy. Windows 11, I swear. Okay. So then navigate to your dev folder. Okay. That's where I'm going. And now I'm going to paste this zip file, and then I'm just going to unzip it, extract all. All right, so extract. All right, so once you've done that, you want to go back to your, oh, I'm sorry, should have never closed that window. Users, swodog, dev. Actually, I can just do it here. So do a dir, okay? And there's your C bootcamp, right? So you can remove the zip file at this point, rm c_bootcamp.zip. Okay, and then navigate to C bootcamp, cd c_bootcamp main, cd simple sim. All right, no, so simple sim is all one word. Okay, oh, let's just check it out. Oh, C bootcamp, sorry. It's nested again. dir, and then cd simple sim. Okay, so there's simple sim. Now, at this point, if you probably, you could type, see, this is really what I want to show, and this is why I'm on Windows, right? The very first thing you should do is try to run the program. So run make by itself. Make. All right. Oh. Okay, so I know what the issue is here. I need to close this window and reopen the bash window. That way it picks up those environment variables. Okay, so let me open get bash one more time. And let me just let me enter my password for get. Let me set my text font size again. Sorry about that. Text font, text, select. I think I did 14. Apply. Okay. All right. Apply. Save. All right. So change directory, cd dev, cd c_bootcamp, dir, cd c_bootcamp one more time, cd simple sim, okay, and then make. Clear the screen, make. You should see this, a list of targets, okay. So at this point, you've installed Make in Windows. For you Mac OS and Linux users, you should already have Make. Just download the C Bootcamp repository, navigate to Simple Sim. For you Windows users, once you've installed Make, close your Git Bash window, reopen your Git Bash window, navigate to your Simple Sim directory, okay, which is what I'm calling the project directory here. Let me pull those instructions over one more time. All right, so open, navigate to the project directory. That's where Simple Sim is at. And then just run make, M-A-K-E, right, from the command line. This will give you a list of all the targets, okay, in that make file. So if you do a dir, right, then we see that we've got a make file here. And when we open up this project in Visual Studio Code, you'll see what I'm talking about. But this make file contains targets, okay? And then if we just run make, then make will say, okay, well, here's all the targets in that make file. Which one do you want to run? So for Windows users, this is what will happen if you run. So you can run make all, so let's run make check tools. Check tools. Then it will go, check, it's not underscore, make check dash tools. Okay. So it runs that and it'll say, if it's missing anything, GCC, oh, it's not, we don't have GCC on this machine. Okay. So I will need to install GCC. All right. AWS you don't need. Okay, so you can ignore a missing AWS, but you guys should have GCC, all right? So I'm going to install GCC on this virtual machine. I'll be right back. Okay, I have installed GCC and I've relaunched my Git Bash terminal. So now I'm going to navigate to dev cd c bootcamp /c bootcamp simple sim cls. Now I'm going to run make. We get our targets. I'm going to say make check tools. So you see it's got Git, fine, you don't really need it. Make, great, it's there. GCC, okay, and it say AWS is missing. I can show you how to fix that, but it's not, you don't need to worry about it really. Okay, so now that we have this, I just want to show you what happens. Let's do make one more time. We see the targets. If you can run all, which means that it will set up and build everything, right? So let's run. Then you got check tools, which is what I just ran. Clean. If we do a dir, we see that we've got the makefile, readme.md, and the source directory. And if we do a tree on src, I don't have a tree command. Okay, so if I do a dir on src, then we've got main.c, simplesim.c, and simplesim.h. Okay. Now if I run make setup, then it builds, it creates a couple directories. What it does first is it removes build if it's there, removes dist, the distribution directory, and then builds and then creates these two directories, right? So let's do a dir. And now we've got those two directories, okay? If we do CLS and do make again, so that's just setup, right? We can do a clean and it'll remove those directories, all right? If we do a dir, those directories are gone. So the way I've set up my make files is I chain them together, right? So when I run make all, it'll clean everything, delete those two directories, run setup, create the two directories, and then build, right? Build the application. So I'm going to run make all. Actually, I'm going to run make run, and then this is what you might see. All right. So CLS. If you run make run, now on Windows, on Mac OS and Linux, if you run make run, you'll see the program run. You'll see this on Windows. Oh, this is a pleasant surprise actually, because on Windows 10 VM, it blocked right there, right? Like it didn't show the program. But this is what you want to see, all right? If you don't see this and you only get down to that last, like right up here, if you get to this statement, that'll execute, and then you don't see this piece, then you have to run it manually, and I'll show you how to do that just in case you encounter that problem, all right? But this means that the simulator is running, all right? So if we enter a number, this is what I demoed in class, right? So I'm going to say 20. This is the memory output, right? So if I hit 20, we'll see that right here, this memory location will change. Hit 20. So now the 20 is in memory location, I think that's 10. All right. So now I'm going to enter another number. I'll say 30. Now we got memory location here. And then the rest of the program runs. Now you may be asking at this point, like, what program are you talking about? For those people who were not in class last Thursday, this runs a simple machine language. Okay. Now, if you type make run, and you don't see the computer memory dump, right? And it asking you to to enter a number, then what you do is you type winpty. You can do a dir. We've got the dist directory, right? If you do a dir on dist, we'll see that we've got simplesim.exe, okay, because it built the program. And then if you run this manually, you can type winpty. All right, dist simplesim, and then this should run the program, okay? If it's not running when you type make run, all right? So now, same thing, I'll say 30, and then 30, and then it calculates the sum of 30 and 30. Okay, that's the first step, right? And that applies to, for you Mac OS and Linux folks, you don't have to install Make. Just download the project, get it to run, and then follow the prompts, right? And so that's what these instructions are showing you, right? So if you just follow this preparation, you get to that point. Now, what are your tasks for the project? Once you can run the simulator, add the following features. Feature 1, implement the right instruction. See notes in the simplesim.h file for hints, right? And then implement the load program. So let me move this out of the way. Now let me call code on this directory. All right. So let me make this a little bit bigger. Oops, not quite. There we go. Let's try this one more time. All right, so that's what I wanted, just a little bit bigger on the text. Okay, so this is our project, okay? This is our build directory. This is where when you run make and it compiles the source files for you, this is where it puts the output files or the object files. This is where it builds the final executable. For you Linux and Mac OS people, it'll be simplesim.o, right, for output. And then, or just simplesim, okay? And then here's your source, right? So we have a main, simplesim.c, and simplesim.h. So let's take a look at the make file first. You don't have to be a make expert, right? Make can be very confusing if you've never used it before, and does require some getting your head around. I don't expect you to understand what this code here is doing, right? But check tools is here. Here's the target that actually runs, and it just runs this __ check tools, and it just confirms that it tries to run the commands for the different targets that are up here in this tools array. So tools is an array of strings. So like I could remove AWS, right? If I get rid of AWS, okay, and then hit save. Then it's not. Then if I run check tools, it's not going to check for AWS, right? So if I do make check tools, then it's not checking for AWS, right? Okay. Well, shouldn't be. Okay. Oh, I see right here. AWS version cut. Oh, I added that, so I just hard coded it here. Anyway, don't worry about that. All right. So let's go back to here. All right. All right. Actually, let's just go back to the code. So this is make. So these are the different targets, right? So if let's start with clean. Clean will remove, right, the builder. which is defined up here as dist. Okay. That's the destination dir, and then build dir is BUILD, right? So clean, right? Remove build dir, remove distdir. Now setup, it will run clean first, right? So before setup runs, it will delete the build dir and delete the distdir, and then it will make the build dir and create the distdir, right? And that's the way these things chain together, right? So if I want to build the project like run, it will first call all will call setup, setup will call clean, clean executes, then setup runs, okay? And then all, and so all setup. And then once setup runs, okay, then it goes name, simple sim, right? Consists of the O files. So it's going to build all the O files, right? And this is how it builds each file, right? It's going to build the main. It's going to build simplesim.o. And simplesim.o, these are the commands to actually compile the files, okay? So anyway, make. You don't have to be an expert in it, right? You don't even have to touch this file, I think is the long and short of it, right? You just have to know how to run it. Now, for the main, you don't have to touch this file. Well, maybe, but we'll get to that in a second, right? You should only have to, what this does, it just it imports or includes simplesim.h, and then we've got this main function, and it runs simplesim.h and returns 0, or simplesim :run. It calls the run function. Yeah. Now we're going to do the header file first. The header file purpose is to declare, all right, anything, functions and variables, not variables, but constants and data structures that you're going to use in your program. All right. So what we declare here are the maximum memory, and then the opcodes. These are the opcodes for the instructions. So a read equals a 10, and a read, so what this means is read number from console into memory location. All right, and I'll show you how an instruction works here in a second. We went over this in class, right? Really what I wanted to show you in this video is not necessarily how it works, but just what you need to do for the project, right? Here are all your function prototypes. We've got a run, a load program, a demo, initialize CPU, and a dump CPU. We got all the opcodes defined. We got true and false defined. And then we have a structure defined, CPU. And then we have a type def where we say we're going to call this lowercase CPU structure uppercase CPU. Now, where is this file used? This file is used in simplesim.c. So we include simplesim.h, standardIO.h, standardlib.h. We declare a CPU, lowercase here in this case. And then we go, we have our initialize CPU. You don't have to change that. The load CPU, this function here is not implemented, right? So you're going to have to figure out how to load a program, because the way the program is currently put into memory for this version is I've got a load demo, right, function, and I just manually set the program in memory, and I start with read, which is 1010 or 10. So read a number from the console and put it in memory location 10. Read a number from the console and put it in memory location 11. So how do you know what these, 10, 10, 10, 11, 20, 10, 30, 11? Because they're defined here in your header file, right? A read is a 10, a write is an 11, all right? Now, if we go to back to simplesim.c, the first task I'm asking you to do is implement the right instruction, right? So let's see if I got that correct. So we've got this load demo, then we got the run, right? You probably, yeah, and this is where you're going to be doing probably the first task. So you see we've got read, write. Write is not implemented. We've got load, right? I had to implement some of these things to get the simple program to run. Store. Again, go back to the header file to see what these instructions are supposed to do. Add, subtract, multiply, divide, jump, jump zero, jump not zero, halt, and keep going, or default, right? Keep going equals false. Now, so the only instruction that you need to implement is write, okay? Because it's not implemented. So that's not a very tall order. How do you know how to do a write? Go look at the simplesim.h. Excuse me. It says write a number from memory location to console. That's what it needs to do. Take a look at what these other instructions are doing for hint on how to implement that instruction. Implement the instruction, and then you might want to modify this program to actually use a write instruction. Okay? So let's go back to SimpleSim. So write is an 11, right? So read is a 10, write's 11, loads a 20, stores a 20, 21, adds a 30, subs a 31. You can read them there, right? Then once you get that working, then I want you to implement this. Now, there are example code on how to read and write files, text files. All right. So what would a program file look like? I'll go over this next time we meet, right? After the spring break. So anyway, that's the tasking that I want you to do. All right. For you advanced folks, I might even ask you to build a compiler for, and I'll show you what I mean by that when we talk about this stuff next time we meet. But anyway, that's a project overview. Hope this was helpful.